All right, so let's go through these problems. The first thing you have to do is read through the whole sentence before you start writing anything, because you want to figure out what's your reactants and which are your products. So sodium metal and chlorine gas react to make. So there's our yield sign. These two are our reactants, and this is our product. So we're going to put them in the right spots, and we have to write the correct formulas after we decide, is it a single element? And if so, is it diatomic or not? Is it ionic or is it covalent? Because we got to pay attention to the right rules, or at least apply the right rules. So we see sodium metal. That's a single element. The next question you ask yourself, is it diatomic? Do we have to put a 2 after it? So we look at a periodic table and we see sodium over here, and sodium is a single element that is not shaded in gray, so it is not diatomic. So we're just going to write Na. And it says metal, so we're going to put an S. Now we got chlorine. Chlorine, is it diatomic? I don't know. Let's go check the periodic table. Here's chlorine. It is shaded in gray. That means it's one of those guys that has to form pairs if it doesn't have anybody else to bond with. And it's a gas. And then it makes solid sodium chloride. So at least we know it's solid. And it's sodium chloride. So we know it's not a single element. Is it ionic or covalent? Covalent, a dead giveaway, is prefixes. I don't see any prefixes. And ionic means it has to have a metal there, which sodium is. So we know it's ionic. We've got to figure out charges if it's ionic. So you look at your periodic table. Sodium has a +1 charge, and chlorine has a -1 charge. So now that we know, and it helps to write the little charges up here, now that we know the charges, we can look at them and say, hey, that's a 1-to-1 ratio. So we can write NaCl. Now notice that the Cl2 over here does not match the Cl over here. When you write a formula, when you write the formula for sodium chloride, you don't care about anything else but that compound. So you have to apply the rules for that compound regardless of the other substances that are there. Don't let that 2 influence you. Don't go putting a 2 here just because there's a 2 there. So once you've written all the individual formulas, then you can go back and take care of those things by balancing it. So over here we got 1 Na, we can make 1 sodium chloride. Great. We got 2 chlorines. Sodium chloride only needs 1 chlorine, so that means we're going to have an extra. Remember, the rule is if you have extras, you got to build more products. So we're going to make 2 of these. If you make 2 of them, you can use up both your chlorines. That's good. And you also need to have 2 atoms of sodium to start with. So we're going to make this a 2. And this is fine as a 1. So there's our first example. Now the next one. A solution of ammonium hydroxide will form when nitrogen trihydride gas, this is one of our reactants, is mixed with water. So nitrogen trihydride. We know it's not a single element. Is it, we'll put single, is it ionic or is it covalent? Well, I see prefixes. The prefixes are a dead giveaway, it's covalent. Plus, neither one of these is a metal, so it can't be ionic. So I'm going to use my prefixes to write my formula. N, and then I see a prefix here, tri, comes after the H as a 3. So it tells me there's 3 H's. Nitrogen trihydride gas is mixed with water. You all know the formula for water. It's a liquid unless you're told it's water vapor. And then it makes a solution of ammonium hydroxide. So we know it's a solution, AQ. Ammonium hydroxide. Is that a single element, ionic or covalent? Well, it's certainly not a single element. Is it ionic or covalent? Well, it can't be covalent because I don't see any prefixes. Plus, I see 2 ions. Ammonium and hydroxide are both ions, so it has to be ionic. So we need to know what those ions are and what their charges are. So ammonium and hydroxide. Let's go back to our handy dandy periodic table. Here is ammonium, NH4, and here is hydroxide. So we're going to write the formula for ammonium hydroxide. Ammonium is NH4 with a +1. Hydroxide's OH with a -1. We now look at that and say, hey, that's perfect. 1-to-1 ratio. So we're going to write 1 ammonium and then 1 hydroxide. And then if you go to balance it, we got 1N, 1N, 3 H's plus 2 H's. That's 5 H's. Over here we have 4 plus 1, 5 H's. And then 1O, 1O. This is already balanced. Number 3. We got pellets of sodium hydroxide will neutralize, it's doing something with, a solution of carbonic acid and produce both water and solid sodium carbonate. All right, so what can we do quickly here? Well, pellets of sodium hydroxide, we know are going to go there. We'll deal with that in a second. A solution of carbonic acid, we gave you the formula for acid, H2CO3. And anytime it's an acid, it's always dissolved in water, so it's aqueous. It's going to produce both water, so we know that one, that's a liquid, and solid sodium carbonate. So sodium carbonate is going to go here. Now, we have to decide what rules to follow. So again, we're thinking, is it a single element? Is it ionic? Or is it covalent? So sodium hydroxide, not a single element. Is it ionic? Yeah, because sodium's a metal. We know it's not covalent because there's no prefixes. So we go through that mental process every single time. Now that I've concluded this is ionic, I've got to know my ions. And we already looked up the charges of sodium and hydroxide. We know sodium's +1 because we did it over here in problem number 1. And we know hydroxide because we just used it over here, it's a -1. So that is a 1-to-1 ratio, NaOH. And it says pellets are solid. Now, it's going to produce water and solid sodium carbonate. So we've got to go through the same exact process for sodium carbonate. We know it's not a single element. It is ionic because sodium's a metal and carbonate is a polyatomic ion. And it can't be covalent because we don't see any prefixes. So we got to know the charges. We know sodium's +1. Carbonate. What on earth is carbonate? Well, it ends in 8, so that's a clue to you that it's one of these polyatomic ions. So if you don't know what it is off the top of your head, which you probably don't, you got to come look it up. CO3 -2. So little sodium's trying to give away 1. Carbonate is CO3 with a -2 charge. So that means it's trying to take 2. So 1 sodium does not make 1 carbonate happy. We got to have 2 sodiums. So we crisscross these charges because they're not the same. So now we're going to write our formula over here. Na gets the 2, and then we write 1 carbonate, just CO3. That's sodium carbonate. Now we go back and balance it. 1 Na, 2 NAs. That won't work. We better start with 2 of these molecules, not just 1. Now, the coefficient 2 goes to the hydroxide also. I don't see hydroxide on this side, but I do see water. And water really is a hydrogen and a hydroxide. So we can treat the hydroxide different than the hydrogen. Just separate them. So if I want 2 hydroxides, I can get 2 hydroxides here. Just have to put a 2. That also gives me 2 little H's, which is perfect because that's what I have here. And I see a carbonate and a carbonate. So everything's balanced. 2, 1, 2, 1. Number 4. I got solid zinc oxide and sulfur powder are formed when. So these are my 2 products. When zinc, sulfur powder, and oxygen are allowed to combine. So this is my first reactant. This is my second reactant. First reactant. Here we go. Is it a single element, ionic, or covalent? Well, not a single element. And it's not covalent because I don't see prefixes. So it's ionic. If it's ionic, I need to know the charges. So zinc sulfide, look up here. Here's zinc. In the box, I see a +2. Here's sulfur, and I look up and I see -2. Notice it didn't say sulfate. It says sulfide, so it's regular sulfur. So we got zinc as a +2, sulfur is a -2. That's a 1-to-1 ratio. I wouldn't know that unless I actually looked up the charges, so I can just write 1 of each, ZnS. And it's powder. Powder is a solid. Then I get to oxygen. Is it a single element, ionic or covalent? Well, it's just oxygen, so it's a single element. So if it's single, I have to ask myself, is it diatomic or not? So we go here, here's oxygen, it's shaded gray, oxygen is diatomic, O2, we know oxygen's a gas. We don't even have to be told. So there's my formulas for my reactants. Now I have to worry about the products. Solid zinc oxide and sulfur powder are formed. So this is my first one I'm going to deal with. Is it a single element, ionic or covalent? Well, it's not a single element. It is ionic because it has a metal, zinc, and we don't see prefixes, so it can't be covalent. So it's ionic. If it's ionic, I got to deal with charges. So zinc plus 2. We know that because we looked it up over here. Oxide is oxygen. What's the charge on oxygen? -2. So again, zinc and oxygen make a 1-to-1 charge, so we write one of each. And it's solid. And then we see sulfur powder. Is it a single element, ionic or covalent? Well, it's just sulfur, so it's a single element. If it's single, I gotta look to see if it's diatomic. So I go over here, here's sulfur, it's not shaded. That means it can hang all by itself, like that. And it's powder, so we put S for solid. So now we go back and try to balance this. We see zinc, one zinc, that's good. One sulfur, so far great. Oxygen, we break down this one molecule and there's 2 of them. But we try to build this and we only need 1. So that means we're gonna have an extra leftover oxygen. So what do? If you have extras, you've gotta make more products. So instead of building 1 of these, remember everything's imaginary 1, we're gonna build 2 of these. So we can use up both my oxygens. But I also need 2 zincs. So I better start with 2, not 1. So now I got my 2 zincs. And I need 2 sulfurs, so I better change this. I'm gonna end up with 2 sulfurs. So this stays a 1. All right, number 5. We got a solution of lithium hydroxide will form when, so lithium hydroxide is gonna go over here, when solid lithium oxide is added to water. So we can do the water real quick, H2OL. But let's start with our reactant lithium oxide rather. We go through the same process. Is it, a single element? Is it ionic? Or is it covalent? So lithium and oxide. Well, first up, it's not a single element. And I don't see prefixes, so it's not covalent. It's gotta be ionic. If it's ionic, I gotta know charges. So I look up lithium. Here's lithium over here, and I look up and I see it's +1 charge. So +1. Oxide, remember we just did this over here. We said oxide is -2, -2. That is not a 1-to-1. Lithium can only give up 1 electron, oxygen needs 2, so we're gonna crisscross, and that's our formula, Li2O. And it says solid, so we put S. Now over here, we're dealing with lithium hydroxide. Same process. Is it single? No. Is it covalent? No prefixes. Is it ionic? Absolutely. This is a metal, and this is a polyatomic ion. So 2 reasons why it's ionic. So lithium makes +1. We know that. Hydroxide we dealt with earlier. Hydroxide is OH -1. We need to know that. So then we look at that and say it's a 1-to-1. So I write 1 lithium and 1 hydroxide. And now that that's all set and it's a solution, so put AQ, we can balance it. So 2 lithiums, I need 2 lithiums here. Now I see an oxygen and an oxygen. I can distribute and I see the oxygen. And over here I see 2 hydrogens, 2 hydrogens. So it's all balanced. All I had to do was change the 2 over there. But again, if you got this formula wrong, then everything would be impossible to balance. Number 6, aqueous solutions of lead nitrate and sodium iodide react to make. So those are my reactants. They're going to make a precipitate of lead iodide and aqueous sodium nitrate. Now, each of these has a metal. This one has a polyatomic ion. This one has a metal and a normal non-metal ion. This has a metal, non-metal ion, metal, polyatomic ion. So they're all ionic. So I need to know all of my charges. So lead has a +2 charge. I love seeing Roman numerals. Nitrate. Nitrate is not nitride. So we got to go back to the list. Here is nitrate. It's NO3 with a -1 charge. So I need to remember that. -1 and it's NO3. So I look at those two and I say they're not the same. I got to crisscross. So the 2 is going to go after the nitrate, 1 goes after the lead. So PB and then NO3, and I'm going to put a 2 after it. I do not want 32 oxygens. I want 2 sets of this group. So I put that in parentheses. And it's aqueous solutions, so I know that this is aqueous, and solutions is plural. This is aqueous. So aqueous solutions of lead nitrate and sodium iodide react to make. So I got 2 solutions. Now sodium iodide. Sodium plus 1. What on earth is a charge on iodide? I don't know, so I go back to my handy dandy periodic table and I find iodine. It's over here, and then I look up, 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 and it's a -1 charge. So iodine's looking to get 1. That's a perfect 1-to-1 ratio. NaI. Great. Now, it's going to make a precipitate. Precipitates are solid. So S goes here. Of lead to iodide. Lead's still making +2. Iodine, we already looked up, is a -1. That's not 1-to-1, so I crisscross. PB, and then I2. And aqueous sodium nitrate. Sodium's +1, nitrate's -1. That's a 1-to-1 ratio, so I can just write 1 sodium, and then 1 nitrate. And it's aqueous, so I put AQ. Now I go to balance it. I'm going to start with my polyatomics because I can get a lot of atoms done. There's 2 over here. This only needs 1, so I'm going to build 2 of them. I don't want to have any leftovers. That means I better have 2 NAs available. So I can't start with just 1, I better start with 2, so I can have my NAs. And that's going to give me 2 iodines to build with, which is perfect, because in order to make 1 of these, I need 2 iodines. So we're going to have 1 of these, 2 of those, and we can make 1 of these and 2 of those. Last one. Calcium fluoride was dissolved in water and then mixed with aqueous sulfuric acid. Soon, solid calcium sulfate and hydrogen fluoride gas appeared. So, your reactants are calcium fluoride that was dissolved in water. This is a big way of saying it's aqueous. Dissolved in water just means it's a solution, aqueous. So, I'm going to worry about calcium fluoride. Now, is this a single element, is ionic, or is it covalent? Well, it is not a single element, and I don't see a prefix, so it's not covalent. It is ionic. If it's ionic, I need to know my charges. Calcium +2, fluorine -1. How do I know that? Here is calcium +2. Here is fluorine -1. They're not the same. I crisscross, so I end up with Ca gets the 1, F gets the 2. Dissolved in water. Here's my aqueous. And then mixed with aqueous sulfuric acid. I give you the formula. H2SO4. Soon, solid calcium sulfate. So I've got to look up calcium sulfate's charges so I can write this correctly, because this is definitely ionic. Calcium's a metal, and 8 is a polyatomic ion. You got to know that. So what are the charges? Well, we know calcium's +2. Sulfate, if you don't remember it's not sulfide, it's sulfate. So you got to look over here. SO4 -2. So you make a little note, SO4 with a -2. So I got a +2, -2. I can write a 1-to-1 ratio. 1 calcium, 1 sulfate. Perfect. And hydrogen fluoride. So the hydrogen and the fluorine, if we look, this is kind of an odd one, but hydrogen makes a +1 charge. Sometimes it acts like a metal in that way. And fluorine over here makes a -1. So we can just write HF. It is a gas, so we put a G. And then we just balance. So we got 1 calcium, 1 calcium. We got 1 sulfate, 1 sulfate. 2 fluorines. Oh, only 1, so I'll put a 2 here. And that also impacts my hydrogens, which is perfect because I got 2 hydrogens. So I've got 1, 1, 1, and a 2. And those are 7 problems that you should be expected to do by now.